You mentioned Jupiter, and one of our viewers just asked, could it slingshot around Jupiter and head back toward Earth?
Yeah, that's in principle possible because the speed of the object, 3I Atlas, is 60 kilometers per second, which happens to coincide with the escape speed from the surface of Jupiter. Jupiter is not a solid object, it's a gaseous planet, a very massive gaseous planet, may have some rock at its center, but it's also diffuse, and it's a gas giant planet. And but at the surface of Jupiter, the escape speed of if you wanted to launch a spacecraft that would escape Jupiter, it would need to have a speed of 60 kilometers per second, which is exactly the speed of 3I Atlas.
Harvard astrophysicist Avi Loeb has suggested a possibility that the interstellar object 3I Atlas could experience a gravitational slingshot due to Jupiter's massive gravity. This intriguing concept involves a phenomenon known to space scientists. By passing close to a giant planet like Jupiter, objects in its path can be redirected and accelerated using the planet's immense gravitational force. For 3I Atlas, already traveling at astonishing speeds of 60 kilometers per second, this gravitational assist could alter its course, possibly bringing it into Earth's orbit, an unexpected event that could have far-reaching implications. While the idea of a slingshot redirecting an interstellar object is not new in the context of space exploration, the scenario becomes more compelling when we consider the strange and unprecedented behavior of 3I Atlas. Originally thought to be just another comet, this object has defied expectations with its anti-tail, a gas and dust plume pointing directly at the Sun, a phenomenon never observed in typical comets. This, along with the highly symmetrical jets emanating from the object, has led scientists like Loeb to propose that 3I Atlas could be something more than a simple cosmic rock. Could it be an alien spacecraft deliberately sent on a journey through our solar system? The questions surrounding its nature are as mysterious as the object's path. In 2026, 3I Atlas is set to make a close pass, 53.5 million kilometers from Jupiter. While this distance might seem vast, Jupiter's immense gravitational influence could be enough to affect the object's trajectory. If 3I Atlas were to come too close, it could be slingshotted, changing its course and speeding it toward Earth. This gravitational slingshot effect is a real possibility, though not certain. The risk lies in the object's incredible speed and the unpredictable nature of space dynamics. 3I Atlas's most striking feature is its behavior, which has raised significant questions among astronomers and astrophysicists. Unlike typical comets we've studied in the past, this object does not follow the usual patterns we would expect from a natural interstellar body. First and foremost, 3I Atlas exhibits an anti-tail, a plume of gas and dust that points directly at the Sun, a phenomenon never observed with comets, where the tail typically extends away from the Sun due to the solar wind pushing gas and dust particles outward. Instead, 3I Atlas's anti-tail, pointing toward the Sun, suggests that something unusual is at play. This anti-tail is more than just a curious feature. It could be the result of some kind of directional control of gas and dust, potentially indicating that the object is not simply a natural comet. The mechanics of the anti-tail raise intriguing questions. How does it maintain such a direction? Why does it not behave according to the expected pattern? These observations have led astronomers like Avi Loeb to propose that 3I Atlas might be more than just a piece of cosmic debris. It might be something intentionally engineered. In addition to the anti-tail, 3I Atlas exhibits an even more remarkable feature. It displays highly symmetrical jets of gas and dust. Unlike the erratic, irregular ejections typically observed in natural comets, where outgassing is often influenced by solar radiation and heat, these jets emanate from very specific and organized points on the object. The symmetry and consistency with which the jets appear to emerge from the same regions on 3I Atlas raise profound questions about the object's true nature. In the case of typical comets, the jets form when the Sun's heat vaporizes material on the surface, causing gas and dust to be expelled chaotically in all directions. Yet 3I Atlas appears to deviate from this pattern. The behavior of its jets is far more structured, indicating that there may be an underlying mechanism actively controlling the emission process. The jets do not randomly shoot out from different points on the object, but seem to originate from fixed regions, with their symmetrical arrangement pointing towards something systematic rather than accidental. This organized outgassing behavior strongly suggests that the object could be operating under some form of control or mechanism as opposed to the passive outgassing we see in typical comets. This kind of behavior challenges the very principles we've applied to understanding the nature of interstellar objects. Normally, when objects like 3I Atlas pass through our solar system, we expect them to follow predictable patterns, chaotic gas and dust emissions in response to the sun's influence. But 3I Atlas doesn't follow these conventional rules. Its jet-like emissions not only appear to be planned, but they also exhibit remarkable symmetry that would be difficult to explain by purely natural processes. For Avi Loeb and other scientists working in this field, this anomaly is a crucial clue. Could the object be artificial? If so, the behavior of the jets could be interpreted as propulsion mechanisms designed to control the object's movement through space. Much like spacecraft use controlled thrusters to adjust their orientation and trajectory, 3I Atlas's jets could serve a similar purpose. The fact that they appear to be systematically ejected from specific points on the object further suggests a deliberate design, possibly part of a highly controlled process, rather than the random byproducts of a natural object passing through space. Loeb has suggested that the peculiar features of 3I Atlas might point toward a technological origin. Perhaps it is not a natural comet at all, but rather a spacecraft sent deliberately to explore or travel through our solar system. If it were a spacecraft, the symmetrical jets could serve as propulsion or stabilizing mechanisms designed to adjust its trajectory as it moves through space. Such a design would be akin to how human-made spacecraft adjust their orientation using carefully controlled jets or thrusters. In this light, the perfectly symmetrical and organized nature of the jets raises the possibility that 3I Atlas is not just a random piece of space debris, but could very well be a probe or artifact, potentially even a relic of an advanced civilization. Furthermore, the unusual speed and trajectory of 3I Atlas add weight to this hypothesis. The object is traveling at 60 kilometers per second, an incredibly high velocity compared to typical objects in our solar system. For natural objects like comets or asteroids, such speeds are highly unusual, as most objects follow elliptical orbits influenced by the sun's gravity. However, 3I Atlas is coming from outside the solar system, and its speed is too high to be simply explained by the gravitational pull of the sun alone. If it were merely a chunk of debris, it would not be moving at such a velocity unless it were part of a much larger event or process. The fact that it is entering our solar system at such high speeds on a trajectory that doesn't quite match the typical patterns of comets suggests that 3I Atlas might have been deliberately directed or set in motion with a specific purpose in mind. The idea of 3I Atlas being a probe sent from another star system is not one that can be dismissed lightly, especially when considering its travel through our solar system. If the object is indeed artificial, its strange behavior would make sense as part of its design, possibly a probe sent to explore or gather information on our solar system. This theory also aligns with Loeb's broader thinking about the potential for extraterrestrial life and the possibility of objects from other civilizations making their way into our solar system. Yet, despite the possible technological origin of 3I Atlas, there is still a significant chance that the object is entirely natural. Its unusual behavior may simply be the result of its composition and its unique trajectory through space. The object's rapid movement through our solar system, speeding at 60 kilometers per second, is certainly remarkable, and it could be that 3I Atlas is simply a cosmic relic traveling through interstellar space, carrying with it the dust and gas of a distant star system. While we can't rule out the possibility of it being a technological artifact, we also can't ignore the fact that it might be a natural object, whose peculiarities are simply due to the complex interactions of gravity, solar radiation, and interstellar particles. What we do know for certain is that 3I Atlas's trajectory through the solar system is unlike that of any comet or asteroid we've encountered. This object is coming from outside our solar system, from an unknown part of the galaxy, and its path is far from predictable. The fact that it has crossed into our solar system at such high speed without a known origin or clear explanation for its unique characteristics makes it one of the most intriguing objects to study. As 3I Atlas continues its journey through the solar system, astronomers are carefully tracking its position and movement. The most critical moment will come when it makes its closest pass to Jupiter, the largest planet in our solar system. Jupiter's gravitational field is massive, and its influence could have a profound effect on 3I Atlas's future path. The upcoming encounter, scheduled for March 2026, presents a unique opportunity to see whether Jupiter's gravity will alter the trajectory of 3I Atlas and potentially bring it closer to Earth. This is the moment where the possibility of the gravitational slingshot could play a role, redirecting the object's course in a way that brings it within reach of our planet. Scientists are particularly interested in the interactions between 3I Atlas and Jupiter's gravity because as of now, the object is moving too fast to be captured by the Sun's gravity. It is on a trajectory that will take it out of our solar system once it has completed its journey, making this encounter with Jupiter one of the last chances to study the object in detail. If 3I Atlas is deflected by Jupiter, it could be forced into an entirely new path. If that path leads it toward Earth, albeit in a distant future, it would offer a new set of questions for both astronomers and planetary defense experts alike. The potential for 3I Atlas to be deflected by Jupiter's gravity means that we might not be entirely prepared for the implications of such a change. If the object, whether natural or artificial, begins to head toward Earth, scientists will need to act quickly. There are still many uncertainties surrounding how to detect and track such objects once they are within our vicinity, and the case of 3I Atlas would require a global collaboration of astronomers, space agencies, and planetary defense systems to ensure we understand the threat, if any, it might pose. The future of our interaction with this object, whether it is an important scientific find or an unexpected collision hazard, will depend on how well we can understand its behavior as it moves through our solar system. As it stands, 3I Atlas remains a profound mystery. Whether we are observing the final moments of a natural comet passing through our solar system, or if we are witnessing the first signs of a technological artifact from another star system, we cannot yet say for certain. What is clear, however, is that 3I Atlas has captured the attention of the scientific community, and as it nears its encounter with Jupiter, we may be on the cusp of uncovering something far greater than we ever imagined. The coming years will be critical as astronomers continue to refine their observations of the object, using advanced tools like the James Webb Space Telescope and upcoming missions to Jupiter. These instruments will provide us with the detailed data necessary to answer the fundamental questions about 3I Atlas. Is it a natural object? Is it an artificial probe? And most importantly, what role will Jupiter play in its future path? The answers to these questions could not only reshape our understanding of 3I Atlas, but also our place in the universe.